There we go. All right, we're broadcasting live now, so thank you for everybody watching live and watching after the fact for joining the demo today. I'm going to go ahead and get things started. As a reminder, we're running work around 25. So starting us out in changes, Dennis, if you want to kick us off by showing us live CD builds, if you're ready to do that, we'll start there.
Sure. Let me just share my desktop. Switcher. All right. So we added to Koji some new commands where we can use Live Media Creator to make live CDs. So let's just quickly show them all. So we've done a whole bunch of different ones in Koji. Mostly they're working fine. The root file system of a lot of them have had to become a lot bigger because for whatever reason they're coming in bigger. So we'll just dig into one of the workstation ones real quick. A big difference between Appliance Creator and Live CD Creator and Live Media Creator is that Live Media Creator uses Anaconda underneath to do the installation. As a result, we get all of the log files from Anaconda. So when things go wrong now, there's not one log file you need to dig through, but you actually need to dig through all of them to figure out what was the reason for things going wrong. So you can see there's a whole bunch of log files. I'll just quickly go to one that failed and see if we can figure out why it failed. So it actually, it didn't like the SCM. We fixed that in Punji. Let's go to this one then. So the Anaconda log is standard Anaconda log. Lots and lots of noise. But so it gives you an indication that the following software marked for installation has errors. This is likely caused by an error with the installation source. Nothing provides kf-anaconda-server equals the version needed by kf5-anaconda. So it's a packaging bug in the KDE package set that has caused it to not to fail to install. So that's a pretty trivial error to find. You can also see the same error by going to the packaging log, and at the bottom it will show you it has a warning and then says error, it failed because of the dependencies, which is reported in the Anaconda log. On the spins list so far, most of the questions have been about trying to figure out where exactly they failed. The game spin is really special in that it failed because it's just too big. I'm trying to remember where that was. I don't know if it was an Anaconda log. Or no. It was actually just in the live media. So the live media dash out is the output of Live Media Creator. And so there's a traceback here that says the squashfs file is bigger than 4 gigabytes, and apparently MacISOFS doesn't like that, and so it aborted making the live CD. So it's working pretty well. We made some minor adjustments to the spin kickstarts. So I'll get a log. The initial was this, which we just added. We had to add some partitioning options. We had to bring up the tell Anaconda to activate the network, shut down at the end of the install. We had to add a couple of extra kernel packages into the package set and some Drucket and make sure that Drucket config rescue is not installed, and include the bootloader config files. And that was it. And then other than that, it's just been adjusting for sizes. I think the biggest was those game spin, I think, was 2 gigabytes I had to add, or 4 gigabytes I had to add to it. It needs some work. But that's the basic. The changes to the kickstarts were pretty minimal. The changes in Koji were not trivial, but they got done. And we're able to make live CDs in Koji using Live Media Creator and get all of the output that we need. So it's a pretty big win that we're able to get rid of the dependency on Live CD Creator for live CDs, and we just need to work on enabling the rest of the outputs that we want going forward. So that is it for me.
Cool, thank you, Dennis. So we'll be showing demos of those other artifacts as we go forward because we're having those conversations now, but this will be the first one we get for alpha. Lubos, you want to run us through the compose report?
Yes, ma'am. So last week, not really last week, the last demo, I talked a bit about the metadata that Punji is creating when it does a compose. And the compose changelog tool is actually a thing that takes the metadata and it can display difference between 2 composes based on that. So I'll try to share my screen and run through the output of it. The tool itself is not very interesting. The fun part is what it generates. And essentially, the input to this tool is just 2 composes. In this case, I'm showing difference between 2 composes that were generated 2 days, one after the other. And it gives us the list of that there were 31 edit packages, 2 packages were removed from the compose. A bunch of packages were upgraded, some were downgraded. There are the sizes that changed. And then finally there's the list of all the packages that changed. Now this file that I'm showing right now is actually the brief report in that it only lists the names of the packages. If we go to the verbose one, this is kind of more fun in that for all the edit packages we see difference in its size and details. But the interesting part is the upgraded packages that also list the changelogs of what actually changed in the package that was in the old compose and in the new compose. So for example, in the star cluster, we see that the version was bumped a little, and the changes were there is now a patch for PyTest failures, whatever that may be, and it was rebuilt for mass rebuild. So this is the second file that gets generated by the tool, and the last one is in JSON so that it can be easily processed for other purposes. Like if someone wants to do something with that, whatever that may be. And that's pretty much it for me.
All right. Thank you, Lubos. Reminder, because I don't think I mentioned this at the start of this, for anybody who's not in Freenode in #Fedora-meeting, we are there, so if there are any questions or comments that you'd like to leave as we're going through this, feel free to leave them there and we'll keep an eye out. But next, I'll hand it over to Luke to give us a run through of the changes he's been working on. And Luke, if you wouldn't mind giving just a little intro into what we're doing here, because I think this will be new.
Sure. Can you hear me okay?
Yep.
All right. So yeah, last year we started working on a redesign of our release engineering automation workflow. And let me share the screen real quick. We came up with this kind of workflow as like an ideal scenario where everything is kind of driven by Fed message. And what I'm going to demo here is Fed messages coming in from Bodhi whenever a stable update gets released to the world. And we were initially calling this prototype Relengotron, but you know, we came up with the name Outhouse as kind of an inside joke a while ago, and now it's an outside joke. So that's the name of this prototype. So what I'm going to demo now is this little chunk of the workflow where a new update gets released to the world through Bodhi, and that triggers a Fed message. And Outhouse consumes that Fed message and then queries the product definition center to see what components are affected by this change. And then it goes off and recomposes ideally whatever needs to get recomposed for that change. But in this demo, it's purely atomic OS trees. So what I'm going to show is we're going to simulate a Fed message, Bodhi Fed message for a kernel, and Outhouse is going to query our production PDC instance, and that is going to tell us that the Docker host, atomic host, was affected by this kernel, and then Outhouse is going to recompose the entire OS tree. So let me take a step back real quick. This prototype is hosted on Pagure, and at a high level, it's designed to be a framework for automatically rebuilding, testing, and releasing products whenever their components change. So, like I mentioned, it's a back-end Fed message consumer that listens for events and then queries our product database to see which artifacts are affected by the change, and then it will trigger the composes of the change. Trigger the composes of whatever needs to be updated based on that change. And in this example, it's going to use the Fed message atomic composer tool to rebuild the OS tree. And I implemented this a while ago, and currently Bodhi uses this module to rebuild the OS trees during the updates push process. And it has a command line tool, Python API, which is what we use here. And as you can see, it's really simple. And yeah, let's go switch my screen over and do a demo. All right, can you read the font? Yes?
Yes.
Cool. All right, so since this is a Fed message consumer, this runs in the Fed message hub. I'll just fire that up. And it's just sitting there waiting for Fed messages. So over here, I can simulate a Bodhi Fed message. And I'm just going to echo a chunk of JSON to the Fed message logger and pretend that it's at the update complete stable Fed message topic. So this is basically pretending that a new Fedora 23 kernel had just reached the stable updates repository. So when I do this, it's going to scroll pretty fast. So I'm going to go over and scroll up. Here we go. You can see it received the message, and the atomic handler noticed that it's a relevant Fed message. And then it goes ahead and queries PDC to see what artifacts are affected by the kernel package. And then it realizes that the Fedora 23 atomic host is affected. And then from there, it goes and calls the atomic composer tool, which I showed you. And that spits out a lot of output. This is just the configuration file right here. And it's already done, but let me scroll up. There we go. So what it does is it fetches the Fedora atomic Git repository, which has the configuration, the tree file configuration, and it clones it, and then it writes out a mock configuration and a yum configuration, and it spits out the config files there. So it dynamically generates a mock configuration file and a yum configuration file to point to whatever repositories it needs to. And then it writes out a custom tree file for the OS tree and a custom repo file. And then right here, I know it's hard to read, but it's running within mock in this custom ch root with this custom configuration. It's running rpm os tree to compose a brand new Fedora 23 atomic host using this custom tree file that it wrote out, and does that. And for here, it's in this scenario there was no updates, so no changes since the last commit. So it was basically a no op. And then after that, it updates the, let's see, after that it updates the OS tree summary file, and that's it, RPM OS tree complete. And then it updates the summary file. And that is it. It was successfully composed based on a Fed message. And if I go over to this little terminal over here, I can see that this OS tree has the proper ref, and it completed within less than a minute as it was a no-op. So let me just go through this code real quick. Actually, let me switch back to the workflow for a second so I can show you what it's based off of. So this workflow here, there's this thing called the PDC updater, which Ralph Bean created, and it consumes Fed messages and then updates PDC with all of the products and things that they're comprised of. So what I did with Outhouse is I took the PDC updater, and Ralph created a really great API for writing these handlers for various types of Fed messages. So I basically started with the PDC updater code, and let me go back to it and show you the atomic handler. So here it is, and as you can see, it inherits from a base handler class, and then it basically just finds the group type, which is a PDC component group that it's looking for. And here's the Fed looking for, so for Bodhi, completed Bodhi updates. And it looks for anything in PDC that is the atomic Docker host component group for this handler. And when a message comes in that it can handle, it pulls out the Bodhi builds, packages from the build. That is right here, basically filters all the component groups to see if any are the atomic host type for this release. And then it goes over each group and says, all right, for this kernel package, does it intersect with any of the components of this group? And in this case, it does, so it is affected by this update. And then from there, it just triggers a new atomic compose. And as you can see, it's very simple. Couple lines of code, and the atomic composer does all the heavy lifting. And that's it. So in the future, we can easily build these handlers for various other components, such as repositories, live CDs, installers, any type of artifact in the PDC. So yeah, this is a first iteration of a prototype to just see how easy it would be to react to Fed messages, query PDC, and automatically recompose the affected components. And in the future, once these things are composed, this tool could potentially keep things from going out to the mirrors until our QA systems all give it the thumbs up. So once this is done, it could trigger another Fed message that Taskotron could be listening to, and then it could do all of the automated tests. And then once Taskotron sends a Fed message out saying that things are successful, Outhouse could flip all of the bits live to sync them out to the mirrors. So, yep, that's the demo. This is first iteration prototype of Outhouse.
Hooray! Thank you for the tour of Outhouse. No one's ever said that. All right, so we'll be doing prototyping on that side with Luke until we have the end state that we want to be actually implementing. So Dee Gilmore is working on that now. Hopefully we'll have something that we can talk through for the next demo here that walks through what that workflow looks like. But then we can start plugging things in. So the last thing that we're going to demo here is the last bit of the sign repo work that Jay has been working on for Koji. So Jay, do you want to take us for a run through that?
Sure. I'm trying to share my screen. That's exciting. Oops. This might take a sec.
It'll just be awkward while we wait. It's cool.
Yeah, I know. Well, I'm hitting the button and it's not doing anything.
Is it not working better?
Yep. All right, I have one more idea, but it's going to take 2 minutes.
So while we're waiting for Jay to try to get connected or see if he can share his screen, I'll run through just a couple of other things that I think are worth noting, and folks who are here from the team, let me know if I've missed anything. Since the last time we did a demo, I know at the very least we have gotten our PDC deployment into production, so that's all 100% done and live in prod. There's a lot more to add to that, obviously, but it's there. We have all... Adam has been working with the pulp team internally to get all of the pulp packages available in Fedora that we would be using from the pulp side for our layered image work is all ready for us. And then there's been a number of Koji releases to finish up the live media changes and some of the other things that we've been working on there. I'm trying to think if there were any other big interesting highlights for us to mention here since the last time we met, but those are the ones that jump out at me. If I've missed anything, you guys let me know. Looks like Jay's got his screen shared now.
Yep, sorry about that.
No problem, thanks.
All right, so I want to start a little bit high level because I've actually finished the signed repo work in Koji, so I wanted to kind of just recap what's been done so far before I get into the nuts and bolts of the last piece. So there's what we're looking at right now is a pull request in GitHub for the GitHub mirror of Koji. And basically, here's like a quick outline of the usage, which hopefully everybody can see. The features here, the idea here is you can ask Koji to generate Yum repositories of GPG signed RPMs. And this can be useful for building images, for running composes, for putting together updates repositories, and all that kind of stuff. The longer term goal is to be able to make installation media in Koji as well, using this same, using this work. And that way composes could be generated in Koji. And when we have that, then lots of doors open up where we can have developers or testers and stuff like that create their own side composes or test composes instead of bugging release engineering. So the features that we have so far, there's a couple of different workflows that are allowed here. The basic one is that you can specify the Koji tag that has all of your builds, and you specify that and a list of keys. And the key IDs are basically the same thing as the GPG keys that are used to sign the RPMs, and you present those in the order in which you prefer them. So the first key ID you specify is the most preferred, and then it goes less preferred as you go on. And what it will do is Koji will write out every single RPM in the tag in order of preference. And if you want specific architectures, you can do that too. The default behavior is to write every single architecture that's there, including source. And of course, no Arch packages will show up in every repo. The default behavior is to have every package be signed with the keys that you specify in order. But if you want to allow unsigned RPMs in the results, you can specify that, which is here. If you want to write out rawhide or something like that, that might be useful. You can include comps files in the repo data as well, which will make yum groups available. So you could install yum groups worth of packages from a signed repository. You can also specify delta RPMs. And when the repository is being generated, it will delta those. It will delta the paths you specify as it's doing the work. The important thing with this is that it is assuming that the builder has access to the paths you're specifying. So that pretty much implies either shared storage or you're specifying locations that are available on the builder for one reason or another. I figured it was kind of a non-starter to try to send all of the delta or send all of the RPMs you want to delta against, because if you're trying to delta against a previous updates repository, that's going to be lots of gigabytes of data that you need to upload, and that just didn't seem like it would be useful. So it assumes that the paths you specify are already there, and it will warn you if they're not. You can also specify by event, which is in Koji, it has a concept of event IDs, which is the idea where you can specify an event that happened in the past, like say a build gets tagged or a build completes, and it will generate the repository based on the configuration of the tag, meaning the builds that are in the tag at that time. So you can basically reproduce repositories with a high degree of certainty. So it should be fairly easy to reproduce these things from even ancient releases if you wanted to. Multilib I'm going to describe in a moment. No inherit is basically you don't consider tag inheritance when you're writing the signed repo. No wait is basically it makes the shell return immediately. And then skip unsigned is an alternate behavior where if a package is not signed with the GPG keys that you specified, it will just not write it at all. So it's a little bit different than allowing the unsigned ones in there. The output of these tasks looks like this. So up on top is the kind of like the root directory. So this is topter for those of us in release engineering. Below Mount Koji comes repos signed, and then whatever the tag was that you specified, and then a repo ID. And the repo ID is an incrementing number. It's the same table that regular repos use when Kojira is regenerating repositories for build routes. So this is kind of this gives you an idea of what it looks like. So this is the results of a multilib run, which is what I'm going to show next. You can see that in the i386 directory, I just grabbed like a couple of packages for Pigeon, basically. So Finch and libpurple are in here. And there's only 32-bit, and here's the repo data. And then in the 64-bit piece, there's 64 and 32-bit packages sitting in there. And the important thing here, you just have to kind of trust me on this, but libpurple devel is a multilib package, but libpurple itself is not. And the reason it got in there is because a yum transaction was executed so that it does pull in dependencies of multilib packages. And let me get into that now. But I just want, this is the pull request. You can take a look at it if you want. See what code has changed. Next, I'm going to walk through what this what the work took. Everybody can still, I hope. Maybe.
Yeah, we can see it.
Okay, good. In MASH, which is a release engineering tool that generates signed repos, I pulled out the multilib specific code and put it in its own Python package. So to take a look at this, I'm not going to walk through all of the code, but the gist of it is every multilib method is available in here if you want to use it. Every one of these objects, so each method is represented with an object here, and every one of them has a method called select. And what you're going to do is you pass in a package object, a yum package object that is, into select, and it will return true or false depending on whether or not it is a multilib thing. The multilib code itself is kind of widely perceived to be complicated and gross. So what I did as part of this work was I wrote a little bit of a testing framework to gain some confidence that this is actually doing what we expect. So in this package, there's a command, which I'm not going to bother running, but you can give it, you basically specify a package to, or a path to a compose to this, and what it will do is it will run through all of the directories, and it will walk the directory tree, and it will figure out which packages, which 32-bit packages were included with the 64-bit ones. Basically getting the results of, the expected results of this multilib code. Ideally, if you were to run the same exact compose with this multilib code instead of mash, you would get the same package set, the same 32-bit package set, and so that's what this generates, is basically some test data. And then test.py basically does exactly that. It compares test data with what multilib code would do. And in the Fedora space, that's been working really well. I tested with Fedora 23 and 22 and was getting the results the same. So the takeaway there is that I'm pretty confident that the multilib code here is actually doing what we expect. So with all of that said, let's finally get to demoing this work. So what you do with a signed repo request is you're going to use the multilib option. And what does that take exactly? It actually accepts a configuration file, which looks like this. That's not that clear. The idea here, this configuration file gets deployed with that Python 2 multilib package, and in it you can specify sections by multilib method that you care about. So we use devel for Fedora right now, and it's important to note that devel unions its lists with what is in runtime. So that's why both of them are defined here. So basically, if you have a blacklist for runtime and you have a blacklist for devel, it's going to consider both of them. Whitelist is blank for whatever reason. That's just like a historical kind of thing. But anyway, this is where you specify white and blacklists for packages you do or do not want included in multilib output. So we're going to pass something like that into there. Over here. Give me one moment. This is the kind of thing I had set up all before I had to restart my window manager. So this is the command I'm going to execute, and you can see that I'm specifying both i686 and 64-bit x86. I gotta specify the keys manually here. This has been like basically whenever I make significant enough changes, I just run this and make sure that everything still works. Oops. And away it goes. Now, when you specify multilib, something special happens where Koji is only going to dispatch the 32-bit tasks first. And the reason it does that is because when it does the 64-bit tasks, it actually has to pull 32-bit packages from somewhere. So it uses the results of the previous tasks to get that easily, instead of recalculating all the paths and stuff. So it's just like a little small optimization here. So in this we can see it shouldn't take very long, but it's going to go ahead and do the 32-bit stuff first, and then we'll see that close, and it will go to the 64-bit next. And then I can, while it's doing that, actually, I can show what the web UI looks like. So if you've used, I don't have the pretty skinning or anything like that. This is just my devel instance of Koji that I have deployed locally. But yeah, you got your options there. It's running through these tasks right now. Here's what the results of a finished one looks like. It's not all that exciting. The create repo log can be useful to figure out if there's been something went wrong. Perhaps you gave the wrong path for delta RPMs or something like that. If I go back to here, ta-da, we're pretty much done. This is using that multilib package that I separated out. So Koji is actually, the Koji daemon is actually importing that code. Have it there. And there are the RPMs it included. And in the 64-bit one, you can see there's a couple of 32-bit ones that made it in here as well. And that's
okay. So I don't see any questions in the IRC channel, so if you have them, we'll stick around there for a little while. Otherwise, we'll be in #Fedora-Relunch if there are questions that you think up later and you're just dying to know the answers to. Is there anything else that anybody from the team would like to raise or show or ask before we drop? All right, well then we'll be back in about another month and we'll give you an update from there. I think that's it. So thanks everybody for joining. The demo will be recorded and viewable on YouTube as always, and the link will be posted on our demo videos Taiga page, which is included in the invite that you got. So feel free to go back and rewatch at your leisure. Thanks everybody.
Thanks.